Vectorization of raster pictures. In this setting, all pixel images are vectorized and embedded into the drawing as an entity solid. All solids that have clothes the same color will be connected to create one common solid. This option is ideal for colorful pictures or bad quality scans. Fill small holes in pixel traces. This setting fills the small holes in the pixel traces. Fill all holes in pixel traces. This setting allows all holes in the pixel traces to be filled. Close open pixel traces. Often older scanned drawings will contain open pixel traces. This setting will prompt the program to close these open spaces. Under For Experts Only, the user can select the distance between pixels. Cleanup of free pixels. Often older scanned drawings will have free pixels. Selecting this feature will ensure the removal of these unwanted pixels for a cleaner converted file. Thicken pixel traces. This setting will add a layer of pixels to the outer edge of the pixel trace. Thin the pixel traces. This setting removes one layer of pixel from the outer edge of the pixel trace. Assign chromatic colors to layers. This setting assigns the entities from different layers a separate color. On this kind, the user can see the better layer separation on a screen. Enhanced recognition of hatch boundaries. The program will try to find separate vector and hatch areas from in-common pixel traces. Repair raster pictures using blurring. A good method to repair bad quality scanned images is to blur these images and then convert them into black or white images using the threshold. By blurring, the free pixels are removed and the holes in the pixels are closed. Vectorize small elements as lines. The program vectorizes all small pixel traces in line using the center line tracing method. Convert digital photos as hatch entities. Solid. The program vectorizes digital photos as color fillings in the form of an element solid. Solids are very fast rectangle hatches using CAD systems. Output images in original resolution. When selecting this option, all raster images are handled in their original resolution. For large raster images, enabling this option may cause the resulting DWG or DXF file to contain millions of solid hatches. Limited dimension of raster pictures. When selecting this option, all pixel images are first scaled so that none of the dimensions are over the maximum values specified. The proportions of the image are not changed. Handle raster images in black and white. When selecting this option, the vectorized image is first converted into a black or white image and then vectorized. The threshold value of the color, black, is used. Handle raster images in RGB or index colors. When selecting the option, the contrast in color will be increased and then the image will be vectorized. The threshold value of the color black and white for the color is considered. Ignore white color. If this option is selected, all pixels which are brighter than the threshold of the color white in color images and brighter than the threshold of the color black in black and white images won't be converted. This creates coherent hatching without any white spaces in between. Contour finding and cartoonization digital photos. This program function helps to find the contours in digital photos. Contour can be explained simply as a curve joining all the continuous points along the boundary having the same color or intensity. The contours are a useful tool for vectorization of digital photos. Contour finding methods. This program offers 5 different contour finding methods. First, Canny method. This method was invented by John F. Canny, a professor for computer science at the University of California, Berkeley. Canny's method is based on a gradient operator. The key idea here is to use two different thresholds to determine which point should belong to a contour. Second, Sobel method. In Sobel's method, we apply directional filters to detect edges in raster images to create contours for the vector image. Third, Schar method. The method of Hanno-Schar is a modification of Sobel's method for edge detecting in raster images. This method is preferred when more accurate estimates of the gradient orientation is required. Fourth, Laplace method. The Laplace method is named after its founder, Pierre-Simon de Laplace. The Laplace method uses the simplest elliptic operator to detect contours. Cartoonization. The method of cartoonization creates solid hatches of digital images, which is reminiscent of the appearance of cartoons. These hatched areas are made from DWG element solid.